Okay, I am back again. Just wanted to discuss, well, first of all, actually, just looking at this, I complained about the way I was writing this, like solution dot maxstep self and all that. I can just do self dot maxstep and self dot maxstep here. Cleans it up quite a bit. Good syntax to know. And then so actually, I was I was watching NeetCode, and what I'm doing here is like a DFS, like a depth first search solution with recursion, because we're going as deep as possible in the left subtree, as deep as possible into the right subtree. But you can also do something where, like, instead of looking at like how deep you can go, you can look at levels. Like, you can look at the first level here, then the second level here, and the third level, and you get what I mean. And this is like a more of an iterative approach, BFS, breadth first search. And usually that's like more relevant for graph questions, but I was curious, like I was intrigued that it can also be applied to trees in this way. So I want to try and implement that. What I'll do here is I'll just kind of set level. I know I want to do level plus equal 1. I also know I want some kind of a queue structure. What if well, actually, let me just keep going. So I'm just adding the root into the queue. And then while we want to like traverse the queue, go through all of the elements in one level, and then add all the elements from the next level, right? So for I in range length of queue, does that work? I don't know. I don't know if that works. For node in range queue, or for node in queue, I feel like that's better. Thing is, like right now this like root is in a list. Is that gonna cause problems? I don't know. Q dot pop left. I mean, hold on. I actually don't need to track that, so I'll go back to doing this. It seems something wrong with this. I don't know if I can take the length of a queue like a DQ, like a double-ended queue. But I know I can like make this a node. I think when you pop, it will save, and then if node.left is if node.left, then you want to queue like append to the queue. And if node.right, then you want to append that to the queue as well. You're adding like the next level. And then inside here, you want to increment the level. So this is probably wrong. Let's see. Oh, it's okay. Apparently you can do that. I guess length is applicable to any iterable. Like, it doesn't have to be a list. So why like, what if so hold on, let me try running this first. No, it is equal to pop left. Okay, I just messed up the how do I bring back the code? Oh, there we go. It's not capital L. And res. I want to return level. Cool. So what if I get rid of this and just do root like this? Tree node object is not iterable. Interesting. And then how does that, like, when you append node.left, node.left is a subtree though, right? So shouldn't I be like appending it like this? With a list around it? Well, let's see. Okay, well now that's giving a problem because list doesn't have a left subtree. Well, that's confusing. That was just my alarm, no need to worry. Okay, well, I mean, I'll try submitting this, submit that. Okay, still in there. I guess space complexity is added, you know, O of n time complexity and being the number of nodes in the tree. But then space complexity, like it's this queue that can be up to the number of nodes, like O of n space complexity as well. I think, maybe I'm wrong. Or since maybe it's based on level, it's not that much. But, well, yeah, I mean, this is a good solution to keep in mind. Like, there's always like I'm noticing there's like an iterative solution or an recursive solution for a lot of these scenarios. And it just expands my perspective when solving these questions. And apparently NeetCode said there's like a iterative BFS solution using like a stack and trying to like reproduce that stack rather than like actually doing recursion. So I thought that was interesting too. But I'll leave that for another day. I think kind of exploring the original solution and then exploring this BFS solution was enough. I also noticed I didn't have to import collections. Like usually I have to do like from collections import DQ. But I noticed I didn't have to do that, which was interesting. An extra L. Yeah, okay. Maybe it's like imported by default. But you know, worst case, you always want to assume the worst case. And when you're not giving these import statements. Yeah, alright. That's enough for today.